go ahead and open it and take a look at it. And this is really good, very self-explanatory. Tells you about the exam, the detail of it, how to prepare for it, how to take the test, and it has answer key and everything, and frequently asked questions. It's a really good document. So I tell you the important ones that I want to go with you through. So these are the typical thing that you see in the CSWA exam. There will be 3 questions with 5 points, so small credit, that they will be on drafting. So although CSWA is mainly on part and assembly, but there will be some simple multiple choice questions on drafting too, okay? For example, what is this view? Is that a section view? Is that a detail view? We're gonna see problems like that in this PDF. So you're not gonna really do any drafting and put all the dimensions and tolerances on, no. It's just a multiple choice question to see if you know the basic tools in the drafting, okay, and basic drafting principles. You're not going to do real drafting for this exam. Then the major thing is part design, basic, intermediate, and advanced, and there is 2, 2, and 3, 7 questions of 15 points that you need to do: sketching, bus extrude, cut extrude, changing dimensions, doing revolve, doing circular pattern, and then for advanced, you need to do offset, you need to do difficult geometry modifications, and so on. So one of the things that I suggest, and we'll go through it, you'll see, is to use parameters and equations, so that when you want to modify, you just go and modify the parameter or the number instead of modifying everything from scratch. That would be impossible in the time frame of the exam. And then finally, you will be given some parts and you're going to do some basic assemblies, okay, and modify that. So overall, you have 14 questions. Now, don't forget that the assembly questions carry a big weight. So 4 of them, but it's 30 points. So these 4 questions of assembly is 120, and these 7 questions of part design are 105, and then the 3 questions of drafting are only 15 points together. Okay, so assembly is half of the exam, although it's not really hard, but you need to do it and you need to know it. Total 240 points, and you need, I assume, about a little more than 2/3, right? 160 is 2/3 of that. It's like 65% or less than 65%. A little more than 60% you need to pass this exam. So it's not really bad, right? It's like in your classroom you got a D or C. If you get a C, for sure you would pass it 70%. And you have 3 hours to take this exam, so please allocate 3 hours on the day of the exam. Now, here mentioned the places that you can do more practice, but mostly when you go there, it gives you these files that I'm sharing with you. Now, the important thing is about taking the exam. For taking the exam, you need to have a SolidWorks account, and if you don't, you can go ahead and create one. The best thing I suggest to you is you directly come and click on this virtual tester on SolidWorks. When you go there, this is the same link I send you today through email. And when you go there, then you can click on the software here, Virtual Tester Pro. And this guy is the software that downloads as an executable file, and you can run it. And when you run it, let me show you. then it asks you to either sign up in the system for SolidWorks, or basically if you have already user and pass, use it to log in. But once you do that, here, so you choose your language. You can do it in other languages too. And then comes this page here. So if you haven't been to this website and never created any login info, go ahead and provide it here and continue. Otherwise, you can go and say, yes, I have a user pass, and go ahead and do it. Again, if you don't do it here, create one and then come back here and use the username and pass to get into the system. When you go there, the good thing is it shows you all the exams that you have taken, which one did you pass, which one you failed, what grade did you get on each one of them, and so on and so forth, okay? So this is a good environment, and you can get your certificate and the grade immediately after the exam. So when you log in, then for the exam, since you have only voucher of SolidWorks, click on SolidWorks, then it says, okay, provide your voucher, you type the number I gave you, and then submit. Then it gives you something for the exam, and then you can click on go ahead and start the exam. And when you do, then it will give you a, so for example, I don't have CAD, but that's okay. So you click on that, and I don't want to do CAD, but CAM, Computer Aided Manufacturing, and then you choose the link and go ahead and says, okay, do you want to do it? You say yes, and then comes up this software. Right now, actually, I'm burning one voucher, okay? So, but that's okay. Nobody's using CAM, that's me, so that's okay if I burn this one voucher. I don't know how much was it, but it's good. At least I show you what you should expect for this exam. So it opens up this guy for you. You agree and start the exam, and there we go. Okay, so it says the first thing is probably it's just a yes or no or a check mark, and then you can go to the next question, and then it gives you problems. For some of them, as I said, like this, you have to click on the file, download it, and do some stuff on it. Then gets the number that it is asking you. Click and go to the next question, next. At each point you want to know which one you have answered or not, you can click on show summary, and it shows which one you haven't answered and how many points each one does have. And finally, when you are into the last question, then you would go and submit. And it says, okay, are you ready? So you have to do a bunch of things, and again, once you mark off the 15 questions or this time runs out, then the exam would end. And there we go. You can go to that link that I showed you, and you can see the result of your exam. Actually, it tells you right away here whether you passed it or failed. You can just go there to download your certificate. Okay, so here we go. That's what you should be expecting. And you can use the same username and password here to log in. And once you go there, then you can go under, see your exams, whatever certificate, you see how many exams I took, and your credits, and so on and so forth, okay? So hopefully you know how to deal with this exam. Let's see if it just allows me. It is being a little bit unpleasant. Doesn't like me to get away with it, but I want to. There we go. So let's get rid of that. And now let's go through these problems, and I work through some of these problems. Hopefully it helps you too. So these are the 3 simple drafting problems. So here you see this is the main part. Here you draw some S-spline around it, and then you could take that portion off. And then it says which, if you want to create view B out of view A, what type of view you should do. Is that an isometric view? Is B isometric of A? Well, of course not. A is isometric itself. Is that projected? Have you projected this onto that? Of course not. Is that a section view, or is that a crop view? And probably you guess this is a crop view, right? You cropped it using an S-spline. This is not a section. You don't see any hatching. Or like this one here, you see, I drew some S-line and now I could cut it locally. So it says, how would you go from A to B using what technique, what command? Is it an aligned section? Is it a detail view, a section view, or broken out section, which is of course broken out section, right? It's a local section view. And so here you see, I guess it has two problems, but typically it has three. But these are this simple as long as you know which tools in this drafting you should be using. Then you have problems 3 and 4. They both use this part, so keep them. And if you can see, there are 3 dimensions, C, A, and B, which you create the first problem with, and then when you create the first problem with these 3 numbers for A, B, C, and apply material and everything, it says what is the mass of the part. By the way, the number that you provide and the actual number that the problem is assessing you based on should not be more than 1% different. If your number is 5% different than the number this online grader has in its memory, it's gonna mark you as false instead of true. So you need to make sure the number that you get is very, very close, if not identical to these numbers. If the number is 1028, the actual number, and yours is like 1200 or so, then there is definitely something wrong. And save your files. So as you go through, save your files, because in the next problem you have to modify those parameters and remeasure the mass of the part. So save it, save this like problem number 3, and then open it, change the parameter values, and then save it as problem number 4, and so on. The good thing is, if for any reason you could not exactly get to these final numbers, you can, at the end of the exam, when you have some extra time, if you do, you can go back and open those files and see where you went wrong, and hopefully you can get the file fixed and get the right number. So always create a backup of your files as you go through the exams, constantly. So the thing is, this sketch. This is an interesting sketch with so many dimensions and everything, and you need to create that. And again, you need 3 parameters, C, A, and B, and these are the numbers for them. So when you go to SolidWorks, new part, and then you start on the front plane, and go to sketch. First, make sure the units are set in the beginning right. You see, this is the SI unit, millimeter, mmgs. It tells you even what unit it is using. So before you do anything, change your units to the right unit. And now that the unit is set, the other thing you want to do is see if you can insert those 3 parameters. So I go to Tools under Equations, right? And I try to provide 3 global variables. A, which is 81, 57, 43, right? So 81 mil, then use a tab, go to next one. B is 51, right? 57 and 43, 57 and 43. 57 and 43, and then OK that. And now under this equations, you can see all these 3 parameters. Go ahead and save right off the bat. Okay, so I call this Q3. And go back and now start your sketch. And that's where I said 2 monitors if you have, by any chance. If you can have 2 monitors, that's amazing, because you don't need to go click here, look at the sketch, and then come back and draw, and then you cannot memorize it all, right? Unless, again, you do like a minimize something like this. which is not the most convenient, of course, but maybe that's what you should do. And even if you do, still probably you have to go a little bit back and forth too. And what I recommend when you try to do this is set one of these corner points as a known point. So one of these points, make sure it is at origin, set at origin. I leave it up to you to decide where to put it. It does not matter. To me, maybe I put the center of the circle as the origin. Again, it does not really matter. So what I do right now is I put this on the other monitor I have. You probably don't see it, but at least I can start doing my sketch. So here I start at the circle and I draw the circle, and the dimension for this guy is 14 diameter. Then I use the line tool and I start drawing lines. It does not need to be perfect, just to start approximately, and then you can correct it. Okay, so but just do it roughly correct. So then I go horizontal like this. First, try to do as much straight line as you can, then connect them with curves. Okay, that's a good strategy. So here you have then an angle like this, and then go straight a little bit. Then you have a curve here. So as I said, I would do, that's my strategy. Maybe that's not the best one, but that's how I do it. And here I also have a straight line. And then I go like this. And then this, and then this, and then this. Okay, so these are the lines, and then here I need a couple of curves, right? So I need, actually this part I also have a line with 10-degree angle. And then I connect them with the 3-point arc. So use 3-point arc like this, and again do the best that you can approximately. And here too. There we go. Okay, so it has to be rough in the beginning, and then start applying the constraints. So here, the distance between this one and this one, I start from the left side, that is 32. And then this angle from here to here, this one should be 45, and this one should be also 45, and then the center to here is 14. And then this is 14 also. And then this is 7. And make sure you separate them enough so that you can see everything, every detail. And then what? You have then this one also 7. And then this angle from here to the horizontal in this direction is 10 degrees. And then the radius of this guy is 29. And then the whole height of that is B. This one is 5. Now this one to be 29. And this one to be 45 degrees. and we have 24. Then you have 29. Then we have 19. This radius is 19. And you got most of the dimensions except for A, B, C, D, and this radius here that should be fixed. So we can move this point a little bit here to get it correct. You put this radius of 5 here first. And now let's do A, B, C, D. So A is the total width of the part. So from here to here, you click here, and instead of typing a number, you say this is equal to, then you can go under global variables and choose A and OK that. Right? And you see that's 81. And then B is the overall height. And then C is the depth of the part. So we do that later when we do cut extrude. So now you see some entities still blue. That means they are not fully defined because we have to do a bunch of tangents. So wherever you see the symbol here, this guy, a line and a circle, that means they are tangents. So you have to do that. So here, first of all, turn the dimension off, choose these two guys, and then choose tangents. So that's one thing. The other one is you have tangents here too. So this guy and this one are tangent. So this one and this one. Okay, that's good. I assume I have all the dimensions set here. Now, one of the things is, if you can see here, the center of this curve is on this line, 19 units above the bottom. So that's these two we haven't specified yet, so we have to do it. So we come back and make sure, first of all, this center and this line are coincident. And the other thing is I click on this center, and with respect to this bottom, I make this guy 19 units. Now you see the bottom part is completely black, the top part is still blue. And if you look at the file, there is nothing explicit that we missed. The only thing that might help is if you can see here, I don't know if I can write on it or not, probably, I don't know. Hopefully it allows me to write on it, but if it doesn't, that's okay. This point here, this point, which is the end of this straight line, horizontal line, is right above the origin. So that point and the origin are on a vertical line. That's the only thing I can see is missing, so let's apply that. And so here I choose this point and then origin, and then say these are vertical. And there we go. And if you look at this guy here, actually it is very much like our shape. So I assume we are set, and we exit, and then we give it an extrusion of C units. So say this is equal to, and then we make sure this is equal to C. And there we go. And then if you look at the material is AISI 1020 steel. Okay, so we do that and then we save. Right, these guys here. So this one doesn't say steel, or no, it is. This is polished. This is cold roll. Now they're very similar. It did not provide any more info, but let me just do the basic one. If you look at the density of this, that's the only thing that matters. That's 0.285. This one is 0.284. So let's first go with this one. And that is my part. I'll save it. And now the first thing it says, what is the overall mass? So I go to evaluate, click on measure mass properties, and you see it's 939.54. And if you look at one of these numbers, that's exactly this one. So yes, you got everything set. The constraint was right, the material was right, and that's your solution. So good, I got this problem out of the way. Now the next problem is related to this. So it says everything is the same. By the way, one indication that I forgot is this is the density of the part. So if you are not sure which one of those AISI 10-20 was the material, look at their densities. This can tell you which one. And always read this. The second problem says compare. The material is the same, everything is the same. The only thing is just make it 84, 59, 45 and remeasure the mass, right? 84, 59, 45. So let's do it. So I go to manage my equations and type the new numbers. So this is 84. The next one is, this is 45, and then B is 59, small modifications to the part, right? And you okay that, and then the part will resize itself. And now if you want, you can save this as Q number 4, right? And just make sure you rebuild it. It does rebuild by itself, but now you remeasure the mass, and you see now it's a little heavier, of course, because you made the dimensions bigger, 1032. And if you look, this part, it does not give you multiple choice. So you have to, in the software, in the tester, you have to type the number. And make sure you type exactly this number here, 1032.32. Sometimes it asks you to round it to 2 or 1 or 3 decimals. Mostly it's 2 decimals, so you just copy and paste this number in it, or type it in. Okay, so now this problem is out of the way. Now, the next problems, if you look, still are related to this problem. You have to modify this part and add some stuff to it. So that's what we're going to do. Now you have to do a bunch of cut extrudes in the part, right? There is one cut extrude here, there is one cut extrude here, and a bunch of holes. Right? So that's the same part, still ABC. And ABC are modified. So first go ahead and modify them. The material is the same. And now you have to do these cuts. So first, let's go ahead and modify the numbers, 86, 58. So 86, 58, and 44. Okay, and you save this as now Q5. And now with these numbers, we go and start creating the holes, right? So this hole we already have. Let's make this hole here. So this hole, if you look at it, it is on this front face and is 14 and 14 units off the top corner with diameter 11, and it's true. So let's do that. So we go on this face and start the sketch and use Control 8 to see vertical to it. Then we draw a circle here, diameter 11. And then 14 and 14 off on the corner. Then it's 14. This is also 14. And that's it. And then you go under features, and then you select this sketch, and then cut extrude through all. Okay, so this is the other hole. Now it is time for the two other cut extrudes. So one of them is this cut here, the other one is this one, and you can do any of them that you want first, doesn't matter the order. So if you want, I can do first this one. This one is 19 unit in depth, and it's just the boundary of the sketch where the cutting line is 52 units from the right side. So I draw this sketch here using this 52, and then cut extruded 19 units in. Okay, so again I go back here, and this is what I do. I'm not going to redraw on the top of this, I project them. So I click, hold down Control and multi-select as much as needed, this much and this much, and then this much. Clearly doesn't go to the arc, but if you want you can choose that too, but I just chose these guys, and then I say what? Convert entity. And now they are black. Now, it might be hard to see black on the gray, so maybe if you want, you can go and change the color of the part to something that is better visible. Okay, the problem uses a kind of greenish color, so maybe you want to do that too. Okay, so now these black lines are here, then I draw a vertical line from this edge to this edge, and make sure the offset of that from the right edge of the whole thing is 52 units. Right? Now, you see these two portions are extra, so I use the trim tool and get rid of this and get rid of that. And always use trim to closest, which is the most powerful trim tool. There we go. Now you have your closest sketch. And I go here, and then I cut extruded 19 units. And there we go. This is this one. The next cuts that you need to do is from the top view. You have to draw this rectangle, which is 24 units, 12 from the back edge, rear edge, and then it has some depth. How far do you go in depth? Probably you can see it in another view, right? Let's see. Should be able to see it in one of our views. Of course, it doesn't go all the way in, right? So what you have is, if you look at the mid plane of this guy, if you look at the mid plane, then in the mid plane, you are going so many units to the left, so many units to the right, and the sketch that you need to cut is, it includes these boundaries and then one arc that you have to add, and this arc is shown here for you. The center of it is collinear with this line, 36 units. The bottom of this, the bottom point of this curve is 36 units below the top edge, and the radius is 41. So let's first go to the middle point, the middle plane, and then on that we draw this sketch and then cut it 24 units. So the first thing is that really the mid plane here? Or we can start here and then go 24 units on this direction. So you can create a plane here, it doesn't matter. Let's create a plane here. So I need from the rear plane 12 units inside the object and create a plane there. So this is what I do. This is the rear plane. I click on creating a plane, and then 12 units inside the object like that. And then on this plane, I draw my sketch. What is the sketch? As you can see here, the sketch is this arc, these three lines, that line, right? So 1, 2, 3, 4, 5 entities have to be projected. So this one, 1, 2, 3, 4, and 5. I convert them first. There we go. Then I draw this arc with that center, with that offset, and that radius, right? So let's do it. So I use a 3-point arc, and I connect 1 point here to 1 point there, something like this. Okay. If this plane is on the way, hide it. Right click and make sure you can hide that, right? Or you can come here and hide it. So now this center is first collinear with this line, so you make it collinear or coincident. Then the radius is 41, and then this bottom point is 36. So this bottom point from here is 36, and the radius of this guy is 41. And you see now it's black, means it is fully defined. And now this extra portions, again, you trim. So you go back to sketch, use the trim tool, get rid of this extra portion and this extra portion. And now your sketch is ready. Okay, that is your sketch. And then now you would cut extrude it 24 units inward. That's your sketch. That's your part. Okay, I guess it's all done. The same material, the same everything. And then again, it says what is the overall mass. And how would you know you have done the right thing? If it gives you a multiple choice, that's amazing. You can compare your number against those and see if it matches. If like this, you have to type it in, then you have to rely on how accurate you have done it. But hopefully we have done everything right. And if you look at the mass of this part, my mass is 682, right? And if I go, there is an answer key at the bottom of this for problem 5. Hopefully I got it right. Problem 5, now these are frequently asked questions here. 5, 6 to 8, 18. Look at mine, 682, okay. Mine is 682, this is 628, isn't it? Yeah. That thing is not good, okay? My previous one was 1032, which I guess it was correct. So I can always open my previous one because everything is based on the previous one. Let me first double check this one. So this one was 1032.32, and that's exactly this number. So Q4 for me is perfect, but Q5, look, 628 and 682 are not 1% different. It's way more than 1%. So if I type that number that I see here, it's messed up, okay? I'm gonna lose the credit, and probably since next problem depends on this one, I'm gonna lose again and again. And the bad thing with this exam is every question depends on the previous one. So the smallest mistake you make is gonna ruin everything, okay? So let me make sure what could have gone wrong. First, I come back and check my dimensions, 86, 58, 44. That's right. The material is still the same, I assume. No difference. 0.0079, yes, everything is the same. This sketch was 19 units, 52. So we can always go and check. This is this cut extrude here. That is the sketch. You see that's 52. And the depth of this was 19. Unless I made some mistake, which I don't think, that's right. Then this hole was 11, 14, 14 all the way through. So you can see it here. It is 11, 14, 14 all the way through, so that is right. And this cut again here is, I see something here. this guy. This one I didn't cut. So it's right. All the way to here is right, but there is also one cut here. Look, this guy. This should also go. So I did not cut that part, so I should. So I should use these boundaries, come up 19 units, draw a horizontal line, and then cut it. How far through? You have to see how far it goes through. 19 again. That is also 19. This 19 belongs to this one, and not this 19 belongs to this portion. So I forgot one more cut, which I have to do on here. So you got to be careful. And if you look at it again, it involves both curves. So I involve both curves, in this line, and project them, convert entity, draw a horizontal line, 19 units. Let me just do something like that and see what happens. So I go horizontal. You need to make sure it is horizontal line like that. So first click on it, make sure it is horizontal. It is horizontal, and then provide the offsets. 19. Okay, so that's good. And this sketch looks close to me already. So I go ahead and cut it for 19. But you see, whenever it doesn't show the preview, it means something is wrong. Okay, so if I say 19, it's not going to do it for me. Look, it says it has a self-intersecting contour. So whenever you don't see the yellow preview and it just shows the arrow, means something is wrong with that contour. So go ahead back and fix it. So, oh yeah, because I did not get rid of this portion, I did not trim it. So now hopefully it is closed, but I can always check, right? You can always use a sketch repair and check. If there is any gap or anything, you can check it. You see there is none. I assume this is closed now. And let's see if I use this and cut it in 19 units. There we go. I see the preview. So now this is right. And I save it and I measure the mass, and now it should be 628.18, which the problem said. Perfect. So I got Q5 right. Now I should keep going, and this time I should create a shell type of feature here. Right? So it created a shell. Okay, it created a shell for me. This is the top section. So the only difference is this feature here. Okay, it created a shell, and the thickness of the walls is 111. So this is the shell that you can see here. This portion of it goes deep, and this portion of it is only going to see that back wall with 1 millimeter thickness. So this portion stays, but this other section here, this bottom one, it goes all the way to until you have 12 units from the back wall. So you have to create this cavity. That's what you need to create. And once you create that cavity, then you should be fine to go. So I would not use shell, and I tell you when you would use shell, what might happen. I would use cut extrude and cut this first all the way to here for 1 unit, and then cut this further in until the bottom of it. So first, let's go ahead and click here. And then I can also save this now as a question 6. And let's get started on this. And so I choose all of the boundaries here. That's the area that I should hollow out, right? You can see. This portion stays. This guy is intact. This weird shape here is the one that you have to cut out. So I'm not going to convert it, or yeah, I don't need to. So instead of converting it, I use offset, and I use 1 mil and I reverse it, right? That's what I need to cut in. There we go. So always use convert and offset. These tools are really time saving. And now I need to cut this in until 1 mil to this surface, right? So first thing is, how much is this guy? I can measure it. So I measure this, and this guy is 8 mil, so I need to cut that 7 mil in. So I choose this guy, and then I go ahead and cut it in for 7 mil, and okay that. There we go. Now I have created this initial cavity. Now I need to do the rest of the cavity, which is this guy here. You can see this one. And that one I have to go as much as just 12 units left, right? So this is what I do now. I go on this plane, and now I want to do that cavity, but I need to see that arc. So I put this to wireframe. And now what I need is this arc, this one, this one, this one, this guy, and this portion. I convert them, and I trim anything that I do not need. Like this. And then I'm going to cut this guy in until 12 units left. Now remember, we cut in 7, right? The whole width of the part is C units, which is 44, so 37 left. From here to the back, I can measure it if you want, right? I can always go ahead and measure what is it, the distance from here to here. And it gives you minimal distance, 37. Now I only need 12 of it left, so 25 of it should go. So when I choose this sketch to hollow it out, I do cut extrude of 25 units. And there we go. Now you can see this is hollow. The only thing is this guy here, that is the problem. Look, it's open surface, right? Should I do that? What was wrong? What do you think? So as you can see, this backside exists. This is the section. But the way I cut it, I used the 1 mil here and everywhere else, but here on the back wall, this portion, I did not use the 1 mil. So I used the sketch that goes like this, and then the end of it was this point and not this one. So it is cutting all the way from here to the back, and it did not give me this small ridge here and here, so that's why you see this back wall. You see this open space here, which is quite weird, right? It shouldn't be like that. So what should I do? I need to modify that sketch. Okay, so I go back, and I need this wall here to have 1 mil thickness. So the first thing I do, I choose this one and I offset it for 1 mil in like this. And I'm going to use this curve instead of that one. So let's trim. Trim here, and I trim here, I make sure this is closed. If it's not, I click on this point and this curve and make sure they are coincident. Because if they are not, then you're going to be in a ton of problem. Okay, and there are some more trimming that you need to do instead here and here. So now hopefully this gives me 1 mil thickness everywhere. And we'll see. Now I do not see the wall. You can click on wireframe and watch it. And now you see, now I got this 1 mil thickness all over the place. So I save it. Now if I continue, again, it says what is the overall mass. Let's measure 432. Let's check the answer key. 432, perfect. I got problem 6 completely right. Now 7 and 8, I assume they are assemblies. So yes, so 7 and 8 are assemblies, so now at this point I can get rid of this. For 7 and 8, what you need is to download all of these files which are provided to you during the test and then assemble it the way that this one is asking. And for this you need again 3 angles A, B, C, so you have to again insert in the assembly some overall parameters because in the next one you have to change them. Then you see that this first part on the top of it is the origin of the total assembly. Okay, and then you have to do a bunch of coincident and concentric and angles and everything, and once you do all of that you have 2 long pins, 3 short pins, 4 of this yellow part, and once you do all of that, for these 3 angles, you want to know what is the center of mass for the entire assembly, which should be one of these guys. So the first thing is I'm going to download these files, which I provided for you on Canvas, and I'll start assembling it the same way that you see here. So let's get started on that. So I start a new assembly. By the way, let me make myself off work right now because my office hours is over. There we go, and now it is asking what part. So I go under download here, should be inside here. And you see a long pin, a short pin, and then the chain link, right? That's all I need. So I click on the long pin first. And I bring that up. Now the question is, if I look at the front, top, and right, okay, these 3 planes are not the same as if I expand the part itself, these 3 guys. So the origin of the assembly is not the same as the center part. So I need to make that happen. So if I click on this point, right? If I click on this point, I can put it on the 3 main planes of the assembly. Then at the intersection of them, which is origin, it will also be on that origin. So I click on this and this one, and by the way, first this is fixed, so first let's make sure that it can move, float it. So I click here and then click this one, and then I make them coincident. There we go. And I click this one, and then I click the top plane. And there we go. And finally I choose this one, and then the right plane, and there we go. So now this part, this origin, is exactly on the right plane of the assembly, top plane of assembly, and front plane. and it is under intersection 2, which is origin. Or there is actually origin. You could make life much easier for yourself by all you do is, instead of all these 3 coincidences, what would you do? You just go ahead and choose this guy, and then hold down and select origin, right? And then you make them coincident. That's much easier, right, than 3 coincidences. But if you don't see this, which you should always see, that's another alternative. So the first part is here, and now I can fix it again if I want so that it doesn't move. And now I bring the chain link part and start assembling. So first I bring 1, and then make this one and this shaft concentric. There we go, and then make this one and this plane coincident. Yes. The other thing that you see here is the mid plane of this chain link fence, chain link part, is the same as the x-axis. Okay, so here, if you look, this part can rotate. So you have to fix this orientation. So you can open this and find the plane corresponding to the midplane of it, which in this case is the front plane, as you can see, and make sure this front plane is on the same direction as the front plane of the assembly. This way, if you can see now, the midplane of this chain link is the same as the x-axis. So you have to fix this orientation too. Now you bring in the small pin or short pin, and you need 3 of that. So you can hold down Control and create 3 copies. You need 4 chain link. So I can add 3 more like this by holding down Control and dragging. And then finally I need 1 line like that. So now let's see what we should do. So now we start with the pins. So there are 3 pins that I needed, not 5. Let's get rid of some of them. There we go. And some of these also seems for some reason extra. I don't know. Seems like I copied more than I needed. And 1 more here. So here there are 4 short pins still, so 1 should go. It seems like I copied twice. And now, this one and this one are concentric. This one and this plane are coincident. And this one and this one are concentric. And this one and this one are coincident. And this one comes in coincident, concentric, excuse me, now coincident. Use faces as much as you can, don't use edges unless you have to. There we go. Now it's time to put the angles in. So this one has to go down, this one has to rotate like this, and this one has to go up like that. And now we can create those angles. So let's see if I can insert them as parameters. So I need angle A, which is 25 degrees. Let's see if it allows it. We don't like it. You can look into the units. DEG is all we need. And probably no space. There we go. Then we need B, which is 125 units. And we need C, which is 130 degrees. And okay. Now you can see them all here. So now you would apply these angles to this assembly A, B, and C. So here I go and I choose this surface and this surface, and then I choose the angle constraint, and I make sure this angle is equal to A. If it understands it, well, let's see. It not. It's a little stupid, but it seems like it does not understand it. So I type it in directly. Oh, I have to flip direction. And the problem is you have to say which entity is a reference, because if you look at this, it is below. If I say my reference entity is this one, maybe I have to make this negative. There we go. So now that is right. And I save this, by the way, as Q7 before I forget. And then I start with the end C125. And the last angle is 130 up. Okay, and make sure everything looks right, which this one exactly is matching this one. And now it says what is the centroid of the whole assembly. So you go and again evaluate. And if you look at the numbers, these are 13, 3, and 3. But the numbers of the problem, the suggested numbers are 300 in the X and 80 and 90. Why? Because again, this is mmgs and this is knots. Look, these are inches. So first thing is, although in part you change the units to mmgs, but it doesn't apply to assembly. Here you have to change it again before doing anything, and now do the measure. And now look, 348 negative 88. 348 negative 88, and then what? Negative 91. So that is clearly number 1. I got it exactly right. And in the next problem, all it asks is change the 3 angles and get your numbers again. So let's do that. So I save this. And then finally, I come and also save this as Q8. Actually, remember that these angles are not needed, so all I need is come back here and change these angles. Right, this angle is wanted at 30 now. The next angle is 115. And the next one, 135. That should do it. There we go, save, measure. And now 327, negative 98, negative 102, and I assume that should be the same number in the answer key. We can go and check. Yes, 102, 98, 327. That's it. So this is going through the sample problems. Again, these tips are good. If you take a look, these frequently asked questions, but this is if you can do a basic part and assembly design. So hopefully going through these problems with you together can give you some hint and help for you to pass the exam.